Okay guys, this is the last part of the geometry project, section part 3. So far we have built our nets, we have measured our nets, we've calculated the perimeter of each of these shapes, and we've calculated the area of each of the shapes of the nets. Now we're going to put it all together and calculate the volume of the net. And so I'm assigning this Thursday, and it'll be due in a week, in a following Thursday. And there are 8 shapes to go through. So the first step is take your measurements and your calculations from the Google sheet from before and put it into the new Google sheet. So here's the measurements from the part 1. Here are the calculations from part 2. And now part 3 is going to be this fifth column, 1, 2, 3, 4, 5, the fifth column, that's all the volume of the different shapes. Before I go further, all the equations you guys need are at the end of the Google document here, okay? So if you're looking for equations on how to calculate these, they're all there. I don't want you guys to get too wrapped up on the variables. Like I've said, sometimes this is the base, and now I've changed it, and sometimes this is the base. What you need to understand is how these measurements and dimensions work with each other to give you the overall dimensions and measurements of a shape. So for the first shape is a cube. And a cube has all the same sides. So for this, remember how we talked about before doing volume, you have to find the shape of the base, and the base is parallel to the other congruent shape, and then multiply that base times the height. So for the area of the volume of a cube, you're going to take the area of the base, which we're going to designate as a big B, and multiply that by the length of this, or the height of the cube. So I've taken this area, and now I'm multiplying it by this height. So this turns into B is A times A, that's the area, length times width, times A. So it is A cubed. So take your measurement for A and cube it, and that will be your volume. Don't forget units. The next shape is a rectangular prism. So for this rectangular prism, it looks like this when it's a 3D object, but this is the net we have made. And when you look at it, we have designated this length times this width as the area of this base. And this base is parallel to the other base. So in order to figure out the volume of the two, I have to multiply it by the height. So again, area of the base, or area of, the base that's congruent and not congruent. It's the exact same, is length times width times height. That's going to be your volume formula. And the base, or this area of the base, is right here. So again, you just take all 3 of these measurements and multiply them by each other to get the entire volume. You take the length times the width times the height. The next net is a right triangular prism, and it's called a right triangular prism because the base, the 2 shapes that are parallel and identical, are these right triangles. So when I'm calculating the volume, I take the area of the base and I multiply it by the length of the entire prism. So here, if I have this here, the area of this triangle, designated by the big B, is equal to 1/2 base times height. Base times h. So this area of the triangle is 1/2 base times height, and then I multiply it by the length of the entire net. How long, the distance between the 2 bases. Again, I don't care whether they stand up like this or not, but when I'm doing volume, when I'm calculating volume, I want to take the area of the base and multiply it by the length. The next shape is this is not a right triangular prism, it's just a triangular prism, meaning that the edge here is a triangle, but it's not a right triangle, meaning one of the sides or one of the angles isn't a 90-degree angle. So when we did these, we measured the base and the height of this triangle. Again, decide these triangles on either side, if I can fold them this way so you can see them more clearly, these are the bases because they are parallel to each other and they are identical. Okay, so first things first is we calculate the area of the base, and then we multiply it by the length in between. So in order to calculate the area of this base, it's the area of the base here is the area of a triangle, which is 1/2 base times height. Okay, so base here and height. And then to get the volume, we multiply it by the length of the entire prism. So this is the volume for a triangular prism. It's 1/2 the base of this triangle times the height of this triangle times the length of the entire prism. Okay, the next one is a square pyramid, meaning that the base is a square, but it's a pyramid, and that the four sides come up together. So in order to calculate the volume, first you have to calculate the area of the base, and the base is a square, so that's just base times base. And then we calculate the volume by multiplying by the height, but not just by the height. What we're looking at is how many of these pyramids do you think fit inside this cube? So when we do that, we fill in 1. Remember, volume is the amount of space. This takes up 2, 3. Okay? So 3 of these pyramids fit inside this cube. So when I'm writing this equation, the volume of a square pyramid, it's 1/3 the big base, the area of the base, times the height. That's a 1/2, thank you. 1/3, because it took 3 of these to fill up this cube. So the area of the base, though, was just a square, base times base. So I have 1/3 times base times base times height, or 1/3 base squared times height is going to be the volume of a square pyramid. The next shape was a triangular pyramid, meaning that the base was a triangle, and then it had triangles on either side to make a pyramid. And it has three sides that are not parallel to each other. But the base is our triangle. So originally when I had this assigned to you guys, I asked you to find the base here and the height here, not thinking that you were going to have to find the area of this triangle. And this height here is not necessarily the same as this height here. This can be you can see there, this height, this length is taller than this length here, okay? So I've now designated them, or actually I haven't in math. It says this one is height 1, H subscript 1, and this is going to be height 2, H subscript 2. So the first step is to find the area of the base, and the base is a triangle. So the area of the base, big B, the area of the base is 1/2 base times height 1. Okay, so that's this triangle here. Then, in order to find the volume, though, we're going to take this base. It's, remember, 1/3 area of the base times the height. But again, not this height of the triangle, but the height of the pyramid itself, H2. Now, if I plug this equation into here, I have 1/3 times 1/2 base times height 1 times height 2, right? Again, we have length, length, and length, so I'm going to get a cube unit, which is volume. Now, remembering our distributive property, I can distribute the 1/3 inside. 1/3 times 1/2 is 1/6. I still have base. I have height subscript 1, which is the height of this base triangle, and then I have height 2, which is the height of the entire pyramid. And that is the volume of a triangular pyramid. Now, let's see if it holds up to scrutiny when we use our macaroni, okay? So, here's my triangular prism. Usually it's just base times height, right? So if I take this triangular prism with my macaroni and I fill it up, I have 1, 2, 3, 4, 5, 6. And it's not precise because these macaroni take up kind of a lot of space. But what I found is that it takes 6 of these triangular pyramids to fill up this cube. So that's where the 1/6 comes from. When I'm trying to find the volume of this, it's 1/6 the size of this cube. So when you guys are working on this, you have measured B, you can measure H1 and H2, and you know how to take 1/6 of something. So just multiply these 3 together and divide by 6 and you'll get the volume of the triangular pyramid. Next is the cylinder. So here's my 3-dimensional cylinder. A cylinder, again, what is the base of the cylinder? It's the 2 shapes that are parallel to each other and identical. So that is a circle. So in order to find the volume, remember we just take the volume is going to be the area of the base times the height, or the distance between these two. And that we had designated as H. So I had to check. So when you guys did your nets, you have your net here. This is my net of a cylinder. When I put it together, so I have this little tiny soup can. And when I open it up, I have a radius here and I have a height. The height is the distance between these 2 bases. Now, this length here is the length of my circle, which is the circumference. So this is 2 pi r is this length, but we don't need that length to calculate volume. All we need is the area of a circle and the distance between the 2 bases. So what is the area of a circle? Base, area of the circle is, what is it, Rebecca? What's the area of a circle?
Pi r squared.
Pi r squared. So I plug this in, my volume is going to be pi r squared times height. And that is the volume of a cylinder. So, take your measurement for radius here, plug it in here and square it, multiply it by 3.14 and by this height, the distance between these 2
Circles.
The 8th and final 3D object is a sphere. So from whatever sphere you found around the house, that is not a sphere, that's a hemisphere, half, right? I want you to have already measured its diameter. So again, hold it up and measure its diameter. Or if you have a hemisphere, that is easy to, very simple to measure this diameter. So once you know the diameter, in order to calculate the volume of a sphere, it is 4/3 pi r cubed. That's what 4 cubed. Again, radius is half the diameter, right? So that is a length unit. You cube it, so my units work out. This is going to be cube units. Then I multiply it by 3.14. Then I want you guys to multiply it by 4 and divide the whole thing by 3. And that is how you calculate the area of, the volume of the sphere. Now there's really good videos online about how they derive this, which is interesting, but I don't have time for that here. Before I go though, one thing I want to mention is I'm using a lot of subscript. Subscript like subway, meaning base, and superscript, meaning super like high, like Superman. Superscripts go on top of the variable up here. So if I have a, when we have used prime before or other superscripts, but for volume, I want you to use the subscripts I put in place. Volume of a sphere, volume of a cylinder, so forth. Sometimes you will see volume with the line across here. That is usually used in physics, but if you do see volume with the line, that's just a V with a line across the bottom. It designates volume. And in physics, that's important instead of velocity or vector.